Hello students, now we'll be continuing with the unit of alcohol. Last time we have finished with the first preparation, that was by hydrolysis of alkyl halide with NaOH, KOH, AgOH, silver hydroxide, and unstable hydroxide obtained by reacting silver oxide with water. I have given certain assignments also. Replaced R with all the different alkyl groups: methyl, ethyl, propyl. In propyl we had isopropyl and N-propyl, and in butyl there were four butyls we did: N-butyl, seg-butyl, isobutyl, and ter-butyl. All the four alkyls with both the halides, bromide and iodide. I've given certain assignment related to iodide for homework. Now the next preparation we'll be doing is by hydration of alkenes. Hydration means addition of HOH, where the HOH it splits up like this as H plus and OH minus. So the H plus will go to the carbon carrying negative charge, and the OH will go to the carbon carrying positive charge. Carbon carrying negative charge means this is a carb and ion, and carbon carrying positive charge means it's a carbocation. So let's see to it how we prepare alcohols from alkenes. Hydration of alkenes. So the alkenes ethene, propene, but1-ene, but2-ene. These alkenes, the gas of the alkenes is passed, alkene gas, this is passed in cold and concentrated sulfuric acid, where it turns out to be into alkyl hydrogen sulfate. Now this on heating in presence of water, it turns into corresponding alcohol, and the sulfuric acid is regenerated in this reaction. Means the sulfuric acid is acting as a catalyst. Now let us see the reaction. First we'll start with ethene. So So the gas of ethene gas, when it is passed in this cold and concentrated sulfuric acid. Let's split the formula of sulfuric acid. So here H is positive, O is negative, cold and concentrate. So here the ethene, the valency opens out like this. So 1 H, it will go on 1 carbon over here. And the negative part will go on the other carbon, OSO3H. So this forms CH3, CH2, ethyl. This hydrogen, and the remaining is sulfate. Now the same alkyl hydrogen sulfate this on heating in presence of water. The OSO3H part goes out with H. It gives back the same sulfuric acid which was over here, and the remaining OH, it will go and attach to this position. So we get the product alcohol, CH3 CH2OH, ethyl alcohol, or IUPAC name ethanol. So this was the reaction with this first alkene. Now next try with the second one, propene, an unsymmetrical alkene. Propene. Propene, this is an unsymmetrical alkene. Unsymmetrical means what? If you see across this double bond, there are 2 carbon atoms over here, right? But here on the left hand side it is attached to a methyl group. It is substituted with 1 carbon, whereas on the right hand side there is no substituent over here. It is only attached to 2 hydrogens. So the propene gas, when it is passed in cold concentrated sulfuric acid, plus O negative. Now here it follows the Markovnikov's rule. In Markovnikov's rule, the negative part of the reagent, it goes and attaches to the carbon carrying less number of hydrogen atoms. So let's write down the intermediate H. So OSO3H part goes and attached to the middle carbon atom. It carries only 1 hydrogen atom. And This remaining H, it goes to the terminal one. So now OSO3H, it's in the middle, it is branch. Branch means iso, 3 carbon atom is propyl, hydrogen sulfate. Now the same thing on heating in presence of water. This part OSO3H, it goes out with one of the H, forming HOSO3H. So the sulfuric acid is again regenerated, serving as a catalyst in the reaction. And the product, the OH, it takes place in that particular position. Again, the OH is branched, right? So branch means iso, 3 carbon atom propyl alcohol, or propan 2 or next is the third one and the fourth. Now the third and the fourth, you will be doing this for us as for homework. But 1 in, the third one is but 1 in, and the fourth one is but 2 in. These two will be for home assignment. Next, we'll see the mechanism of this. How does the hydration of alkenes, or means the alkenes, how do they get converted into alcohols? So we'll study the mechanism of hydration of alkenes. Mechanism of hydration of alkenes. Now here the alkenes, C double bonds, these are getting converted into alcohol OH. One valency is vacant over here, so obviously this get fills up with H. So for that we need a reactant HOH. Now HOH, they cannot get attached directly to the alkene. Why? Because if HOH splits up into H plus and OH minus, when they are separated they are highly reactive, very highly reactive, so that they again combine with each other and again they form the same water. So in order to avoid that, we use a catalyst, and the catalyst is sulfuric acid, HOSO3H. Now how does the reaction works? First, the alkene has to react with H plus. So for that, the sulfuric acid, it provides the H plus ion. Now the reaction is hydration of alkenes, means acid is added in presence of water, or water is added in presence of acid. So water, we have it over there, and water, the oxygen in water, it contains lone pairs of electrons. So this H plus provided by this acid, it goes and attaches to the lone pair on oxygen atom. So this forms H3O. O gets a positive charge, H3O plus. A hydronium ion is formed. Hydronium ion. So through hydronium ion, the reaction takes place. This alkene, it reacts with the hydronium ion. Here, the carbon, the valencies of carbon, they open up in such a manner, the electrons present over here, right, it will shift on one particular carbon. So with shifting over here, this carbon, it gets a negative charge, this remains vacant, it gets a positive charge, right. Now here, this hydronium ion, it splits up in this manner. This H goes out as H plus. The electrons on oxygen are retained as it is. So obviously this H plus from here, among these two carbon, it will go and attach to the carbon with more number of electrons. Okay. So the product in this case is, I'll write down the reaction again, once again. So one carbon, the valences open up this way. One carbon, it gets the H, and the remaining water molecule, it goes out as it is, leaving the electron pair behind, and one carbon is positively charged. So you can say this hydronium ion, it's a positive ion called electrophile. We'll say electrophilic attack of hydronium ion on alkene. So what is happening to the alkene? H plus is added, so it's getting protonated. Electrophilic attack of hydronium ion on alkene. gets protonated to form a carbocation. So in words we can say the first step is what? By electrophilic attack of hydronium ion on alkene gets protonated to form a carbocation. So this is the first step. Now the second step, the OH has to go and attack you. Step 2, OH minus minus means nucleophile. We'll say nucleophilic attack on positive charge, that is carbocation. This was carbocation. We had the H over here. Now the water molecule with its lone pair it goes and attaches over here to the carbocation. The lone pair, so it gets a positive charge, 3 valencies. Now the third step, where finally the product is formed. Now from here the OH will remain attached over here and this H has to leave its place. Means this H will go out in the form as H plus, and the bond will convert into electron pair. Means H plus is losing from that position. It's losing means it is removed, means deprotonation. The term we say is what? Deprotonation. Deprotonation to form an alcohol. So these electron pairs are taken back by the oxygen atom. This H, it loses out as H plus. So the product over here is this H as it is. The oxygen over here, the lone pair, and get back its own lone pair, and the H out is lost out as H plus. Deprotonation to form an alcohol. So these are the 3 steps included in mechanism of hydration of alkenes. So the first step was what? Electrophilic attack of the hydronium ion on alkene. Second, the nucleophilic attack of OH minus on the carbocation. And the last is deprotonation that is removal of this H to form an alcohol. Now the next preparation includes is from alkenes itself. Third preparation from alkenes by using B2H6 diborane. So in short, this is termed as hydroboration oxidation of alkenes. But here the addition, it takes place according to AMR, anti-Markovnikov's rule. Whereas in case of hydration of alkenes, the addition takes place according to Markovnikov's rule. So hydration of alkenes, usually here they give you secondary and tertiary alcohols. Whereas in case of hydroboration and oxidation of alkenes, we always get primary alcohol. So we'll stop the lecture over here. The third preparation, hydroboration oxidation of alkenes, will continue in the next class. Till then, you just revise the hydration of alkenes and the mechanism part. The multiple choice questions and certain questions I'll give in the next class. So we'll stop our lecture over here. Thank you.